Hello everyone, and welcome back to this next video in the Houdini Academy Foundation module. In this video, we are going to wrap up our current chapter on instancing and FBX mesh generation, and we'll be looking into how to create the visualizer for these systems. So right now we have these new visualizers here on our building, and we are going to work on those, meaning that we'll have a visualizer specifically for the objects on our roof, and it will show us where they can be spawned and where they cannot be spawned based on the vent spacing over here. So if I change that value, you'll see that we have more places where these objects can spawn, and those in this case will be shown as green dots for these small vents. But we can also change it over to the large vents over here, which means that now we can see where the large vents are able to place themselves. And we can also disable it. So this will allow us to simply hide the entire visualizer altogether if we don't need it, which is pretty handy because so far all our visualizers are either altogether on or off, and this will allow us to independently turn some of them on if the visualizer is enabled or not. Next to this, we also have this readout over here, which is a text-based readout, and this readout will tell us the current status of our tool, what type of meshes it's outputting, if it's using instances or FBX meshes. It will also tell us if we are applying a material or not, and then it will tell us the current collision type that's being applied. So if I switch the tool back over into, say, FBX copies, then now it will give me information about what type of collision it's using, as well as if it's currently applying a collision for every object as a unique object, or if I switch it over, if it is applying multiple collisions per object. So this type of readout is pretty handy. We can also turn this one on or off right here. And for a user using the tool, this will allow them to see at a glance what they are dealing with without having to actually click on the tool and decode what each one of these is saying, which can be a little bit more convenient for your users, right? Next to that, in this lecture, in order to allow some of these features to work, we will have to make an update to our delete by distance utility node. And since we're already using this node in our entire network at this point, updating this asset has a bit of risk to it. The changes we have to make aren't massive, but we do need to know what we're doing. So I will be going over how we can do this safely, without breaking the utility and functionality we're already using it for, or potentially for other users in our team or in our projects who are using our utilities as well. So it's important that we do this properly, and actually that's exactly where I want to start in this lecture. So let's hop over to the project files and let's get started on updating the delete by distance node first. Okay, so let's have a look at our network over here on the right, where we have our current spawn points. And up here at the top, let's say we look at this node here, the subnet grid spacing S. So this is the current spawn points that we know are potentially valid inside of our building shape for the small vents. Now below that, we are taking our current delete by distance nodes and using them to cull away points that are uncertain conditions. So in this case, we have the points that are too close to the edges. Then we have the points that are too close to the elevators and the staircases over here. And then finally, we are removing all the points that are near any of the large vents that we were already placing. So this behavior here allows us to cull out the points that are too close to any of these elements, so we only have valid spawn points remaining. However, in our case, we want to know where the invalid spawn points are, right? And if we've removed those, then we can't place these little circular indicators on them. So we still need that information. We still need those points. Now, there's a very easy and quick way how we can go about fixing that, and that simply involves doing the same thing as what the delete by distance nodes are already doing. Let's say we grab a group node, and I just create a temporary valid group, right? Let's say we group these points and then we just transfer them. And then let's just transfer our valid group over here. So let's make sure we can see it. And let's give it a very small range, like 0.001. So in this case, we can see that we have a way to filter out fairly quickly using just 2 nodes from our current delete by distance node setup, which points are valid and which points are not. So if you want to, you can continue with that. However, we already have a behavior like this, and it's actually part of our delete by distance nodes, right? When we originally created them, we gave them the ability to group our selection. So up here, if I switch them over to group selection mode, and I change this to say overlap, because now we're actually selecting our current overlapping points, then we now have an overlap group right here, and that's being output from the top delete by distance node. Now let's go to the node below and switch this one over to a group. And now you can see we have 2 groups over here. We have the overlap group, which we created previously, and now we have the group, which is of course the default name that this node is generating. However, the problem here is that if I try to set this one to overlap as well, then now instead of merging our previous group and our selection of points, it's creating a new group here called exclude 001. And that's actually the group inside of this node that we were using to carry our selection throughout this node, and that's a bug. We don't want this to be exposed outside of the node. This is a group exclusively for the interior of this node, and we actually normally go and throw it away, but we're only throwing it away when we're actually deleting our points. And on the right, we were trying to rename it to overlap, but because in this case we have this bugged out situation, this is breaking and we need to fix that. So what we need to do is actually look a little bit more closely at what's actually going on here, so we can deduce the problem and then fix the bug. And then what I want to do is add a secondary mode to the tool in order to union our previous overlap group with the new overlap group we're trying to create in this one. And the reason I want to create a secondary mode is because we are actually adjusting our tool and giving it new behavior. This is behavior that we didn't have, and even though it's a bug, we do have to be careful with what we do with our utility nodes, because we are using it all throughout our network already, right? Over here on the left we're using them over here and up here as well, up top where we have our point selection for the elevator shafts to make sure they don't overlap the staircases. This already is existing behavior, and we do not want to break existing tools, okay? Basically, utility nodes can be shared throughout your team. They can be shared to other people in your network. And if you are the guy that decides to make a change to a utility node that everyone else is using, and they download or retrieve the latest version from, say, Perforce, right? And suddenly the tool breaks on them, all the systems that they built expecting your tool to work a certain way no longer can rely on your tool, and as a result, their tools will break. So we need to make sure that whatever changes we make to our utilities are not going to propagate some kind of different behavior throughout the tool, so other users don't have a break on them. Don't be that guy, okay? Just be careful. Now in this case, what we can do is we can do 2 different things. We could either make a version 2 of our asset, which is what you would probably want to do if you are expecting to change the behavior of the tool and you have no other choice than to do so. And you probably want to do this in case your tool isn't quite deterministic enough that you can reliably expect the output to be the same. So let's say you have a network of paths, right? And those paths have a certain behavior. They snake through the landscape, they have a certain behavior, and you make a change early on in that tool which causes the paths to have a different winding, to have a different type of behavior on how they path the landscape. Well, if people were relying on a certain result and you make a change in your code that causes the pathing behavior to be permanently different, then this might break for other people. And you either have to tell them about this, right, and say, okay, I'm sorry guys, this is going to happen, you'll have to deal with it. Or you're going to have to say, make a version 2 of the tool, and then tell people, well, you can start using this second version of the tool. It will have different behavior, but at least these bugs will be fixed. Now, if you do want to make a version 2, then you can do this fairly simply by simply copying your current asset. And I do suggest you make a copy using the asset manager over here. So what you can do is you can right click, go to show asset manager, and then in here you can find your asset, right? You can right click on that and then say duplicate. And then you could simply go to the names and say v2. And I also have to make sure that the file name itself is different. You don't want to save it to the same asset definition. Technically you can save multiple tools inside one HDA, but this isn't very compatible with the Houdini engine. And in general, I think it's better if you just save it as one tool per library. Okay? That's just a better practice in my experience. So if we do this and we were to save this out, then now we have a version 2 installed in our scene right here. And then we can go and drop this down. So in this case we can say delete by distance, version 2. And then you do have to be careful which one you actually go and update. So if you do want to continue working with this one, I do suggest you replace these nodes with that one. And this might take you a little bit of time, but at least you know that you're going to be using the latest version of your tool. Now, in our case, we don't actually have to do this. We can simply keep working on our existing tool, but we do have to be a little careful as how we go about updating it. Because if I dive inside of this asset and I click on allow editing of contents, then now this node is open for editing and all the other ones are still locked. So any changes I make to this tool here is gonna be applied to every one of these other nodes as well. So let's say I dive in and I add a color node in here. Let's make this one a bright red. Okay. And then if I apply that, save it basically, then all these nodes here, which are currently matching their definition, are also going to have that color node inside, which is the expected behavior, but you do have to keep that in mind. So right now I've basically changed the expected result that comes out of the tool, and anyone using my node will have a red output. That's not something we want, of course, so let's go ahead and remove that again. Let me keep this one rendered right now, but I'm going to save this one. So that's the one I just removed the color node from. And you can see how it's updated. It's now removed it over here as well. Okay, so in our case, let's dive into this particular delete by distance node here. So we have the top one, which currently has its group set over here as overlap. And then this one here also has its group set to overlap, but doesn't have the right behavior. So this is the exact node that we need to go in order to bug fix our problem. So let's have a look at where our bug actually is. So over here in the middle of our network, we can see we have our overlap group and we have our exclude 001 group. Now the problem occurs when we are working with our rename group system here. First, what we did is we created a dummy group, which creates a temporary point group over here for exclude 001, just to make sure that this group combine node does not bug out if this group were to ever be missing. Okay, so that's my safety system to prevent that from breaking. And then below that we have our group rename node. Now it turns out the group rename node does not actually rename a group if the target group already exists. and it doesn't have the other merge behavior that, say, the other group nodes have. So here is a standard group node, and it has this initial merge right here, and it allows us to basically resolve any group conflicts that we have. So we could either replace the group, or say we could merge it. Now in our case, what I want to do is update this system here. So first we remove that bug. We won't be outputting this exclude 001 group anymore. And two, I want to create a second mode, so an alternative mode for our group system here, that will union our new group with our old one. Okay, let's go ahead and fix this bug first, so we know at least that the replace functionality is working properly, and we won't have this exclude 001 group as a leftover. So in order to make sure that our group rename node is always going to work, we need to make sure that the current group that we have is removed before we try to write to it, because we now know that the group rename node cannot write to an existing group. So let's go ahead and create a group delete node here. Place it in front of the rename node. And let's rename this one to remove active group. Okay, then let's make this one red. And up here, I want to plug in the current group name that we're trying to write out to. So let's copy this. And let's plug it into our group name field here for the delete node. And then with that, we should now have this group be deleted before we try to rename the exclude 001 group. So now this replacement behavior is working properly. Okay, so that's one. And then next, let's start working on the union system. So if we have our exclude 001 group and we have our overlap group, I simply want to combine them and write them back to the overlap group, so we have one group that has both. And to do that, we simply need to add a group combine node over here to the right. So let's create one. Plug that in. And I'm going to call this one union groups. Okay. Now, in this case, what we want to do is grab our group name from over here, copy that parameter, and then I want to plug it in up here under our current group name. Now, what this will do is it will override to the existing group called overlap, and then we want to say it equals the current exclude 001 group. So we can just grab it from over here, exclude 001, and then I want to union that together with our current group, so our group name. And what this should now do, if I look at the end result, is it will combine them both into the overlap group. And then next, what I would like to do is make sure that we can actually write out to the correct group type over here. So from our current selection, type the select, I'm going to copy that parameter, which is basically primitives and then points, so 0 and 1. And then up here we have guess from group, points and primitives. So this is reversed. So let's go ahead and plug this in, and then we'll fix it inside of the expression. Let's open this one up, go to edit expression, and then let's write a little if expression in here and say if our selection type is equal to 0, so in this case that will be the primitive mode, then we need to give it number 2 for this one. So let's set 2, and otherwise it's 1. So if you put that inside of brackets like this, and then you apply it, then now what it should be doing is if you set it to points, it will try to write out a point group. If you set it to primitives, it will try to write out a primitive group. So either way should work. And what the group combine node is doing in this case is it's actually creating a new group in the process and it won't need our dummy group here because the first line on the group combine node is what first writes out the group, and then any option that comes afterwards basically gets added on after that group is already created. So at that point it won't error out. Now if we were to try and access a group that doesn't exist, like overlap 2, and we were to flip these two around, right? So let's say we grab group name, we plug this in here, then it will error out, because in this case group 2 doesn't exist, and it tries to get from its own group, which doesn't exist, so it creates an error. But because we were using the exclude 001 group first, and we already made sure that one is created over here in this dummy node, this won't break, and we can continue on from here. So not to get too complicated here, but with that we now have a proper union feature complete. Let's make sure that we set this up properly. So now we have our overlap group, and it's combining both the previous one and our current selection together. And then what I would like to do is add a switch behind this so we can flip either between replacing our selection or unioning our selection, right? So let's create a switch here. Plug that in, and I'm going to name this one replace or union groups. And we'll hook this up to the interface in a second. But there's one last thing that I need to do, and that is to make sure that the exclude 001 group here is always removed from this output, because it is being removed here on the left, so we can copy that, but we need to make sure it gets removed here on the right as well. So now everything should be proper. We now have a way to replace our group here on the left, which is the original behavior of the node, just bug fixed properly. And on the other hand, we have the ability to combine them together. And this is going to be an alternative mode of the tool, so not the default one. And that will mean that anyone else that's using our tool, that's using our utility, won't have to worry about it breaking on them, because it's just an additional option they can enable, but it's not the one they already have set, right? And then last, what we need to do is add the switch node control to our interface so we can switch between our two different modes. So let's open up our type properties, and this should be from your current delete by distance node, the one we're actually working in. I'm going to grab this switch parameter here and plug it in up here above our group name. Okay. Now I'm going to set this one to an ordered menu, so this one, and then under its menu tab I'm first going to fill in these values. So the first entry is going to be replace, and the second entry, number 1, is going to be union. Okay. Now as for its name and label, let's set that one up. So this is going to be called group method. So the method that we're using to apply to our group. And as for its name, well, what I want to do, if I apply this, is have our group name be behind our new dropdown, and then simply move the group name label to this parameter. So it will look like it actually is one combined parameter, right? I actually like to do that because these are very much linked. So over here, what I'm going to do is go to my group name, copy its label, then I'm going to disable its label, then go to the group method dropdown there. I'm going to replace its label with that of the group name, and then down below I'm going to turn on horizontally join the next parameter. So this will make this one sit behind that one, and this one will have its group name. Now if I apply this, it will look like that, and that should work. Next, we also need to make sure that if we set the tool to delete mode, then our new drop-down will also disappear, because at that point we don't need it. So let's go to our group name string, copy its height when condition. And then let's plug it into our new drop down as well. And then finally, before we close this up, let's go to channels and let's make sure it is set to 0 by default, because by default this tool should always try to replace, because that was the original behavior of our tool before we tried to make this change, and I don't want to change the original behavior, right? So let's keep that at 0 and then let's apply this change. Okay, so now we have our option. We can either delete our points and then our parameters disappear, or if we set it to group mode, we can either replace or union our groups. And we no longer have that exclude 001 group over here anymore, so that's fine. If we look at replace, we also don't have it. And let's say I try to specify a group that doesn't exist, like group 2. Well, in that case, we create it, but there's no problem here. If we set it to union mode, then again, there's no problem. It just creates it because it is being created by this node, but there's nothing to merge with, so there's no problem there. Okay, so with that, the changes that we've made here should work. Let's go to the outside of the tool, save our asset, and now it should have propagated all the changes to all the other nodes. So if we lock this asset by matching its current definition, now it should be the time to test your asset. In this case, we don't have too many cases where we were using the group option, and we haven't really made any changes to the delete system here at all. So I'm just going to look over here on the left where we have our grouping system, where we have the elevator points, and these points are currently being removed by our staircase shaft, right? So in this case, this should still work. If I grab this point and I were to move it, let's say I quickly grab the point over here, and if I move it, I create a temporary edit node right over there. So let's make sure we can see that. And then if I move it inside of this staircase shaft, then we can see it is being selected if it's inside of it. So that still works. Okay. And other than that, we weren't using the union mode anyway, because that's the new option. By default, it should still be set to replace in any other nodes that would be using this option. So I think we're fine. At this point, I think we can continue. Let's go ahead and configure these delete by distance nodes so they now work with the group option, so we can keep our points and then we can throw away the selection later for down here. So let's grab all of these, and then I'm just going to set them all to group mode. I'm going to set them to union, and I'm going to set the group to overlap. So with that, now if we look over here, we should be making a group selection and then adding to it as we progress over our nodes. Now at this point, if we grab our selection from the left here, we have all our points available, so this one's going to simply invalidate everything. What we need to do is add a blast node behind these two to then remove the points that were selected. So let's grab a blast node. Let's say remove overlap. Let's specify the group. And let's copy it over to the right, because now, as you can see, we do have a selection of some points that are removed and some points that are kept. So it's working. Let's plug it in over here to the right as well. And then with that, we should have everything set up to continue from here. So that's how you go about updating an existing utility node, the type of steps you should take into account, how to make sure it doesn't break on you. And now at this point, I think we are ready to start working on that visualizer. So let's go over here to the right, and let's create a new netbox right there. And I'm going to call this one the spawn point visualizer. Like so. Since this is going to be a visualizer, I'm going to color this one purple again. And then I want to grab a couple of null nodes to carry some of this data over. So let's go over here to the left, where we have our small vents. And before we blast them away, let's grab this one. And let's plug it over here into a new null node. Let's call this one small vent spawn points. And then let's do the same thing for the one on the left. Large vent spawn point should do. And the next what I would like to do is have the ability to either show the small vents as spawn points on our roof, or the large vents, or to disable it altogether. So let's create a switch here. And let's plug it in. Let's grab a new null node here, which is going to be our disabled null. Then I want to grab my small vents next. And then last we grab the large vents. So we have it like this. Either it's disabled, small, and then large. Let's name this the vent type switch. And then if we were to look at the input, we now have our two different grids. So that all works with our selection. Then let's add some color to these points. So I'm just going to hide my groups for now and create a color node. The color for the small vents is going to be green in my case. So let's call this one vent color small. I'm going to make this one green. And then under its color parameters, let's give them a bit of a subdued color in this case. I don't want them to be super bright. So let's just grab this one. That should do. And then let's copy this and set it up for the large vents as well. So I'm just going to plug that in. This is going to be my large vent color. Let's make this one blue. And over here I'm going to pick, I think this color, 0.51. That should work. So now we have all of our points in this color. And then I'm simply going to grab another color node, plug it in behind, and I'm going to name this one overlap. I'm going to make this one red. So maybe 0.5. Something dark red, like that. And then up here, I'm just going to say the overlap group for these points. So with that, we now have all of our spawn points that are invalid, colored red. And then we can go ahead and start copying a couple of objects on top of them to act as simple indicators. So to do that, let's create a new copy to points node. And then let's create a tube. So let's plug it in like so. And we need to make sure that it's oriented in the right orientation as well. So I'm going to scroll out. I'm going to try and find one of my normal nodes here. Copy this one from our support pillars. This set normal wrangle node, I mean. And then let's go and set up our tube. So instead of primitive objects, we have polygons. Okay. Let's also make them a little smaller because they're a bit too big. Let's set them to 0.25 each in height and radius. So that should do. Then let's give them some caps so they have a top and bottom, because by default the tube doesn't come with a top or bottom. So now we have a solid tube. And finally, I just want to make sure that this one sits on top of the grid. So I'm going to grab its height, copy that, paste it in here, and then I'm going to say multiply by 0.5. So that should now, when we copy these, they should all now sit on top of their points. So that should be working fine. And then let's put them on top of the roof. So over here to the left, where we have our spawn points for the instances, we already have a raise to roof node, right? Transform with a bounding box max for the floor copies. Let's copy this. Let's plug it in over here. So that should be working. I don't think we have an issue with this at this point. So let's add a null node here. Let's call this one out vent visualizer. Make it gray. And let's bring this over to our visualizer output right here. And I'm just going to go and add a new entry in this list. So let's click the plus button. And then I'm just going to plug it in like so. So that should add it over here. Now at this point, I still want to be able to control if this and also the grid are going to be visible when we actually have the tool running. And for that, I want to add a couple of parameters to the interface of the main tool to either turn them on or off. So let me bring up its parameter panel first. Over here. So I just want to add two menus in here. One for our elevator and staircases section, which will involve the grid. So if I make sure I actually see my visualizers. Then for the grid, I want to be able to turn that on and off right here. And for the props, I want to be able to turn on and off these dots or switch them between the different states, right? So the small vents or the large vents. So let's do that. Let's open up the type properties. And first, let's add the vent type switch. So let's grab this switch entry, go down to our prop section, and I'm going to plug it in right below our prop output mode, like so. Let's change this one to an ordered menu again. And then let's name it the vent visualizer. And then for its label, let's call this the vent spawn point visualizer. So this will allow us to turn on and off those points. Then under menu, I'm going to set this to 0 by default, and it's going to be disabled. Like that. Then 1 is going to be small vents, and 2 is going to be large vents. Right. Now by default, I want it to be off, so let's keep that at 0. So now we have our drop down here. Now I just want to make sure that if our current show visualizer option is turned off, then I want to simply disable this drop down as well. So let's go over here and let's copy our show visualizer name. And then under our event spawn point visualizer, under the disable when field, let's just say if our show visualizer is 0, then we disable this option. So now if I disable that, then we also disable the menu option right there. Okay. And then let's add the other one for the grid as well, right? This one. Let's scroll up, go to our elevators and staircases. Let's add a new separator above where we can hide or show the staircases and the elevators. And let's add a new ordered menu here as well. I'm going to call this one the grid visualizer. And then under its options, let's set this to 0 for disabled and 1 for show grid. Now again, I'm going to copy the show visualizer disable when flag from the other one. Plug it in there. And for the default value, I'm going to make sure it's turned on by default. So when we spawn the tool, it will come with its own grid at the top. And then let's apply that. Okay, so let's close this. So let's make sure these two are properly hooked up. Let's grab our vent spawn point visualizer parameter, copy that, and then up here in my vent type switch, I'm going to plug that in. Now in my case this seems to have disconnected. In your case it might still be plugged in if you dragged it into your type properties earlier. And then for the other one, for the grid, I'm actually going to go over to the object merge here, where we have all of our options available. And I'm going to grab this, copy it, and I'm going to plug it into the grid visualizer enable button here. So if I plug that there, then now we can enable or disable it on the object merge itself. So this is one way how we can enable or disable them. The other way would be to just use a switch and a null node. That will work too. But now we basically have the ability to show or hide independent parts of our visualizer. So let's quickly test this out. We can disable the grid visualizer over here. Okay. And then for the props on our roof, we can enable either the small vent visualizer, like so, or the large vent visualizer. That will show us where the large vents can place themselves or where they cannot. So that should be working. We can now bring this into Unreal and test it out. So let's save this up. And then let's go over to Unreal. Over here, let's grab our tool. And in this case, we have updated both the delete by distance node and the main building tool. So I'm going to grab both, re-import those both. And assuming that you didn't change your file location, this should still be working. Then let's rebuild the main tool. And now over here, we should have the ability to view our points. So let's turn them on. Let's say small vents. Okay, that works. We can now hide our grid. Okay. And if I go ahead and set some of these props to a lower amount, like say only 5 of them, then here you can see all the valid spawn points are there. So that's good. That's working. Then next what I would like to do is add the ability to color our individual vents when we're looking at them in FBX mode. So if I turn this into a default Houdini engine color material, then by now they're white. What I would like to do is that if we have one of these two modes enabled, then the vents that are affected, so in this case the small vents, are colored green as well. So let's go over to Houdini again, and I can add this option down here in the database, because our database will actually be able to carry over some color information as well. So to support this, we can simply add a switch behind these two, and then add a color node when this one is turned on. So let's add a switch here. I'm going to make this one purple, because it's a visualizer component. And in this case, these are the large vents. So for the large vents, that's option 2. So let's plug this in twice directly. And then I'm going to grab one of my color nodes from up here for the large vents. I'm just going to plug it in like that. And then I'm going to grab my vent spawn point visualizer. And in the switch itself, what I would like to do is plug this in. But then I do not want this to be colored when our visualizer is turned off. So I'm also going to go under setup, copy our show visualizer toggle, and I'm going to multiply our vent visualizer with that. So if you do that and our visualizer is turned off, then this will be 0. And if you multiply by 0, it will always be 0. So it will turn it off regardless. Then let's copy this. And in this case, if it's option 1, then we want to color it the other one, the small vent color. Plug that in. And then option 2 is going to be the default color, like that. Okay. So at this point, let's have a look at the end of our network, because it already looks like it's working, right? We have blue outputs over here. If we switch it over to small vents, it's green. And if we disable it, it's white. So let's quickly test this out in Unreal and see if this works. Re-import. Rebuild. So we can see it's working. We have our small vents here, they're green. Then for our large vents, they're now blue. And if we disable it, then everything is white. So that's good. But there's still one case where this will break, and that's when we actually use the packed instances instead. And this has to do with how the copy node, or the copy to points node, inside of our loading loop has basically taken on the color attribute, but because this color attribute is now on top of our packed primitives, the Unreal Engine won't see it, so it won't apply the color. So over here in Houdini, what we have to do is basically apply our color from our attribute copy node as well. So it gets applied to our mesh before it gets fed to the copy to points node. So it's actually part of our mesh itself and not applied by our copy to points node over here. So to do this under the attribute copy node, let's go to attribute name and let's add in here our color attribute. Make sure you add a space in between so you have both attributes selected. And then we just need to make sure we visualize our vents as well. So now, down here, our original source object, you can see it has a color. And as long as we look at the output of the node, this should now be working. So let's go over to the end of our network again. Let's save this out. And let's test it one more time. Okay, so at this point we now have our packed instances, also with a color. Let's test this out for the large vents as well. Alright, that works. And when we disable it, it's still all white. So with that, now we have the ability to show the color on our vents, and this visualizer is done. Now with that completed, we still have to work on the other visualizer, which is our status readout over here, and also a couple of other cleanup tasks that we should deal with before we move on to the next part of our toolset, which would be the elevators and the staircases, right? The detailed models. However, I don't want to make this video too long again, so I'm going to split it here and we'll work on the other readout component in the next video. So with that, thank you for watching this video. I hope you found it informative, and see you in the next one. Have a good one.